Today, I have a guest who's a hero of mine. I've known him for a long time. I've done a lot of podcasts with him. It's Richards, J.W. Richards. And he is director of the DeVos Center for Life, Religion, and Family at the Heritage Foundation. He's a senior fellow at the Discovery Institute, and he's the executive editor of The Stream. In chapter 5 of your book, you talk about the pale blue dot. So here's my question. How does Earth and our solar system compare with the thus discovered, the planets that we have, and the exoplanets that we have discovered thus far?
That's right. So when we first wrote the book in 2004, there were about 100 exoplanets that we had detected. It's now, I think, over 5,000, actually.
Say that one more time.
Yeah.
So 20 years ago, we knew about 100.
Yeah. We
now
detected
5,000 or more.
5,000. That's right. And so we're getting better and better. We still can't quite detect Earth-sized planets because they perturb their stars so little. So the first ones we detected, because we're not seeing the planets themselves, what we're seeing is the effect of the planets on the sort of the gravitational interactions of the planets, or the transit of the planet in front of the star along our line of sight. So you can detect either kind of a slight dip in the light, or we have instruments to be able to detect slight wobbles in the star, and then you can sort of infer the orbit and the size of the planet, basically. And so we now know, there's lots of planets around other stars. When the book first came out, I can tell you, think every NASA press release would talk about an extrasolar planet, the most Earth-like planet ever discovered, and we'd look at it, and it would be something like Jupiter, except it would be in this wildly elliptical orbit, spending most of its life inside the orbit of Mercury, right? So a hot Jupiter, completely useless to life. And if there were an Earth-like planet in that system, it would have gotten destroyed by that planet. And so we had this happen so much that I finally started telling reporters, look, call us when you find an Earth-like planet that is as Earth-like as Mars. Because Mars is the most Earth-like planet yet known other than Earth. It is around the star, so we know it's in a habitable system. It's roughly the same kind of size and mass as the Earth. It has some of the same elements. It's only slightly outside the orbit of the Earth. It can even exchange material with the Earth, and yet it's utterly lifeless. And so that tells you, basically, Venus just on the inside of our orbit and Mars on the outside tells you how narrow the conditions are for an Earth-like planet, even in an otherwise habitable system. They're totally lifeless. And then, of course, nobody expects to find life around, in, say, Jupiter or Saturn, which are gas giants, so they don't have stable surfaces, or the outer gas or ice giants, Jupiter and Uranus. What we're doing now is we're looking at some of the moons. So NASA has just sent a mission, it's just taken off to look at Europa, which is a moon around Jupiter. It's a very interesting moon. We spend a bunch of time talking about Europa in the book. And so what's interesting about it is that it has this solid ice surface. And so, as we said, ice floats, so maybe there's a liquid ocean just underneath it, and maybe there's life inside there. Well, that's basically saying, okay, we know life's important, so any place, or water is important for life, so any place we can find water, we'll have life. Well, we're getting ready to test that by going to Europa, and we think, sorry, you need a heck of a lot more. But in some ways, I think that shows you how much we've downgraded things in the 20th century. In the 30s, Americans panicked over Orson Welles' radio program, War in the Worlds, because they mistook it for an actual newscast about Martians invading Earth. Well, no one would fall for that now. We know that there are no Martians because we've actually been there and can see it. And so now what we're doing is we're looking for evidence of liquid water in the distant past on Mars, and we're sending billion-dollar probes to Europa in a moon around Jupiter. So that in many ways, that's the trend line that we've seen, from imagining everything we see from the moon to Mars has life on it, to realizing, okay, well, let's at least try to see if there's water somewhere. The reality is 5,000 extrasolar planets, not one of those is even as Earth-like as Mars. And so not one of them is likely to have life on it.